Welcome to Ladyada.
Hey everybody, and welcome to my desk. It's me, Ladyada. Got some electronics going on here, getting ready for Turkey Day. But before we do that, we're going to do some electronics. So the first thing I want to do is, last week I tried to do a live demo. That's how you know it's live, because it didn't work out. But I thought I'd retry to do the live demo of setting up this round TFT screen using my ICN 6211 board to the Raspberry Pi 5 DSI port. And yeah, it's like totally like crashed and burned. But I tried it again, and this time I tested it right before, so it should be working. So let's go to the overhead real fast, and I'll show where we stopped. So what we had was my, I'm not going to move the board, I'm going to move the camera. ICN 6211 board connected to a large round 4-inch display, 720 by 720. And then over here, it's connected through a cable to a Raspberry Pi 5. And to get it started, to get things like tested out, I have, I covered last week, there's the SPI configuration of the screen, there's the I2C configuration of the ICN 6211, and then there's the device tree overlay. So if we go to the computer, the first step is I write in a loop the all pixels on, all pixels off command. And this is on, there's an ATtiny on that ICN board that communicates with the SPI pins for the display. And so I'm not sending any RGB data to the display yet. I'm just configuring it over SPI. And so what I've done is I kind of lock it in this loop, and I just turn all the pixels on and off. And so I know that I've configured it, because you saw it's like bright white, all black, bright white, all black. That's good to go. So then what I do is I'm going to upload. This is where it failed last time, so like hopefully it'll work this time. I upload the sketch with, I remove that loop. Ooh, look, it programmed this time. Yay, it's programming. To remove that loop, and so now it's configuring the screen. And you know, it happens that this code already has the ICN configuration. But then if I go to my Raspberry Pi, so this is my shell for the RasPi, and I have in here a script that will use the ICN 6211 library that Timon wrote for us, that communicates over I2C with the ICN 6211. And you can like do stuff like set the resolution and the polarities and the porches and the swap order. Sorry, it's late. But what I'm going to do is I'm going to tell it, hey, please put it in color bar mode. And color bar mode, what's nice about that is because it's done internally with the ICN 6211, you don't have to worry about the, you know, any other, it just tests like, did you get the resolution and the sync correctly? Because anything else would depend on the device tree overlay. So let's now run the script. And what it does is at the end, it prints out all the registers. And if you go to the overhead, you'll see beautiful color bars. And that's because this is correct. Now, if I happen to, I'm just wondering, I'm actually kind of curious. If I set the resolution to like 480 by 480, I actually don't know what's going to happen. Let me try it. Yeah, see how it like doesn't look, it's like all messed up now? Because I didn't set the resolution correctly. I told it, oh, you know, you have a 480 by 480 display connected, not 720 by 720. And so this is getting, you see it gets like the first half, and then the VSync is like, it's like, no, you're supposed to send me 720 pixels, and the display gets very sad. So let's go back and edit this to now, oh, you know, the overhead, the computer real fast. I'll just say, show what I'm editing.
What was that?
Can you go to the computer real fast? Yes, I'll show what I'm editing. So this line here, I'm going to change the resolution from I set it to 480. I'll set it back to 720. And I'm also going to turn off the color bar mode. Okay, so you go to the overhead, and actually it still has the color bar, because it turns out what I've realized is once you set the color bars, and they look, this looks funky, but it's not coming through, like it looks fine in person. You actually have to do a hard reset. One thing I didn't do is connect the ICN 6211 hard reset pin to the ATtiny, which I should have, but we have B, we have C, we're going to fix it. So what I'm going to do is I'm going to just touch this to here. You saw that dimmed. It's now in reset mode. And then when I run it now, I turned off the color bar, config. And so you can see now I've got a working desktop on the Raspberry Pi, and it looks great. So this is the 720 by 720 display. You know, I think we did a demo earlier. Hold on, let me see. The only thing is it's upside down. So let's see, video, VLC player, and then I could do video, media, open file, and then we've got a Stargate video that we can, actually let me, it's actually really hard to control this. Hold on one second, make this smaller. And then loop, and then I'm going, there's a full screen mode. Is this full screen? Full screen. There you go. Okay. Looking great. So now, you know, we've got Stargate, which is the goal of like every project is getting Stargate working. So all three pieces are now working, which is great. I have to, you know, as I said, there's a couple revisions I have to make for the ICN 6211. I have to fix the I2C buses because like right now I have all the I2C buses connected together on like this janky breadboard. What I want to do is put in an I2C switch. And what's interesting is I actually have to find, I was going to do it for the great search, but actually I haven't found the part yet. And I have to find the part before I do the great search. I want something that will allow me to connect and disconnect an I2C bus with a GPIO. I don't want to use, I don't want like a mux, like a 1 to 2 mux where you write to an I2C address and then it kind of muxes it for you. I want it to be a, like a GPIO switchable, because this AT-Tiny on here, over here, is used to configure, you know, the SPI port on the display, and then it configures the I2C for the ICN. But then what I want to do is actually turn from controller mode into peripheral mode, because I want the Raspberry Pi to be able to use the AT-Tiny to control the backlight PWM. And so that chip is going to act as a I2C controller for like 1.5 seconds and then switch to peripheral. And then it will be a peripheral for, you know, the rest of its, you know, life on the bus. So I'm going to do that. So I have to revise it. So there's a little bit more to go. But you know, I'm glad the demo worked this time. So it's a mitzvah. Okay, so let's let me sudo shut down. Actually, you know what? I don't have to type in sudo shutdown halt now. I'm going to press the button on the back here. Shut down. Yay! Isn't that amazing? There's like a button you press, and it shuts down nicely. Power off, and then you can see everything disappears. Okay, so let me unplug this because this is a little bit delicate. Okay, and then I'm gonna move this over here. Okay, so the next thing is I'm working on this camera that is Raspberry Pi powered, and it has an LED ring. And so one of the things I got is a bunch of different lenses to test out, and I don't think I'm going to have. How are we doing on time?
You're 10 minutes in.
10 minutes. Okay, we're gonna keep going. I'm not gonna have time to show off all the lenses. I did show them off on I'll do another video, maybe like a short video where I show off all these lenses, but 120, 160, and then what's interesting about this lens compared to these is you see it's got this metal body. That means it's got an autofocusing motor inside of it. These do not have autofocusing motors. It's like you can focus them by twisting the lens, but they're also like wide lens. This one is an autofocus lens, and in here you can see the metal body. It's also an autofocus lens. Autofocus lenses are interesting because basically you give it power over data 1 because you're using only 8, not 10 bits. And then what you can do is send it like the autofocus firmware over I2C, and then you can send I2C commands to do autofocusing. So let's show that off real fast. So this is the camera test firmware. I'll focus. Actually, let me get this in here a little bit. Focus. Okay, so then, oh, sorry, invert. Okay, so then I want to do LED. So what I can do first is turn on the LED lens, which of course is like super bright, but you can see it's an RGBW LED ring. So you can really illuminate what you're looking at, which is really nice. And then, so if I've got like a chip, so like, let's say, you know, I'm taking a photo of this chip, and so this is like a photo of a photo of a photo. But maybe trust me on this. And I hold down the shutter button. Do you see how it like flipped how far the focus was? So then, you know, now this is out of focus again. And I'll hold down the button and it will autofocus. And then if I go close again, you'll see it's out of focus, and I click, pop, and it pops into focus. So this makes it good for doing close-up photography, which you can see now. You can like even as the camera through the camera, you can see the logo and the part number of the chip, which is pretty amazing. So that's something you can do with the this is still, maybe I'll unlock this. You can see. Yeah, I don't know if you can see the lens focusing. Yeah, I think it's gonna be, hold on. Maybe I'll do infinite focus. And then I'll do close-up focus. No, I think it's confused by the reflection, but it does work. So like, you know, the previous demo showing it focusing on something. It does have to have good lighting, I've noticed. So that's why it's really handy that we've got the LED ring. Let's see, click, and you can even hear this little click. So this is kind of nice. Software is done. The PCB design is also done. A couple little tweaks got done. I added a buck converter on this, but otherwise it's like this nice little 3-piece design with a shutter button. And, you know, it's CircuitPython, so you can program it and reconfigure it. And, you know, like even stuff like getting the preview mode. So like it previews as a bitmap, but then you can do JPEG, you know, when you take photos, you know, it'll take a photo and save it as a JPEG for you. And I've got different, you know, like pretty high resolution support. Snap, and it saves it to the SD card. So that's coming. And then lastly, I'll just show a quick board design I did this morning while the baby was asleep, and go to the overhead. Sorry, the computer. We had someone ask for a Grove FeatherWing that was stackable, and oh, mistake. There you go. And I was like, oh yeah, I don't have any Grove designs. And so I decided to try designing a FeatherWing. So, you know, I haven't designed FeatherWings in a while. This plugs on top of any of our feather boards and gives you lots and lots of Grove connectors sticking up. And this is kind of nice because you can like put it on top, or you can use it with the doubler. If you want to still have, you know, if it's like TFT feather and you want to have the TFT display, use a doubler, and then you have this side by side, and you can have 1, 2, 3, 4, 5, 6 Grove ports. 2 of them are I2C, 1 of them is UART, and then 3 are the analog digital pins down here. So I think that's pretty good. I should probably make a Pico Bell with this too. I have to get back. I did a bunch of feathers, and I did a bunch of like metros, and I did all these TFTs. I'll get back to doing some of those Pico Bells and those also the bones boards. I have a couple more I wanted to do. Okay, so we're doing good on time, right, Phil? We can go to the great search.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thank you so much, DigiKey. Every single week, Ladyada uses her power of engineering to help you, yes, you find the things you need on digikey.com. This one comes from a Z tweet eek post.
I know. What
Yeah.
is it?
What is it?
Z, a tweet, a post?
It's a request. We're going to do it.
It's a request. Okay, so this person, Daniel, has a 3D printer, and it looks like it says like Z or Y next to it. So I think this is one of the motors for the gantry of the 3D printer. and you know, whatever, maybe they just yanked the wrong way or got bumped, but the connector came off. And I think 2 of the legs of the connector came off too. And that's why they didn't just solder the connector back on. They actually need a new connector. And they were like, what is this? And apparently the schematics weren't published yet, or the part wasn't published, or maybe they couldn't find it. And so I thought this is another great example of let's try to find this part on DigiKey. I think that's like we've been doing a couple of these. And we'll try to do it live. I did find it, so I can always backtrack, but let's go to the computer and we'll try to locate it. Okay, so we want to have, this is a wire board, and then, so can you flip back to it really fast? That well, I'll ask you to flip back and forth and maybe a couple of times, because I don't have it, so it's like, how do I, I want to prove what it is. So it's a rectangular connector, and you can see by the pads that it's got 2 mounting pads and 4 connection pads, so it's a 4-pin connector. And the second thing you need to know is the pitch. And I'll say that it's actually kind of hard to tell the pitch, except one thing I do know is that to the right, there's some 0.1 pin spacing. And like to the right of the capacitor, all the way to the right of the capacitor, there's some pads, and those are 0.1 inch. And these are definitely closer. So I'd say these are like 2 millimeter or less. It might be like 1.5 millimeter, but it's definitely not more than 2.5 millimeter pitch, because the pads are closer together than those pins. Okay, so back to the computer. Okay, so 4-pin connector, and we know that the pitch is less than 2. We're going to start, or 2.5. We're going to start by just looking for rectangular. We're going to learn how to spell rectangular connectors. Because it's like literally rectangle. So the only thing to watch out for is, there's this, a lot of these categories, when they were started, it was like people used headers only, or like very header-like devices. So it was like, oh, it's a female header receptacle socket. And then there was like a plug, pin, male. And with that connector, it's a little bit unclear, like, is it a receptacle or male, female, whatever. However, we'll start with that, and then we'll move on. So we know that we're going to look for, let's do the stuff we know. We know it's active. It's available right now. We know it's a 1 row, 4 pins, and positions loaded. I'm going to say all in the dash and 4. Pitch, we're not 100% sure, but we know it's less than 2.5. So, and I know it's not 1 millimeter, because that's like a JSTSHs are tiny. So let's apply. So that takes it down from 230,000 to 700. So a lot better. So let's look what we got here. Okay, so we're actually starting to get like, these are much more familiar. Can you flip back to the Zeet? Okay, so I think what we're going to look for is, first off, it's a vertical SMT, and it's got this little like groove in the middle and these 2 notches. Makes it look like a little bit of a happy face if you're looking at like a smiley face. So come back to the computer. Okay, so let's look for normally stocking, so that at least gets us down from 700 to 135. And then we want it surface mount, and it's confusing. Right angle would be pointing out. We want pointing up, which is normal surface mount. I'm like 99% sure. So let's pick that. Now we're down to 38 options. And some of these are looking really good. So these are definitely not it. We want like shrouded. So like these are shrouded connectors. So let's go up and look if there is a setting for shrouded. I don't know if there is. We might just have to ignore those. I think we have to just figure out the mating pitch. That one's, again, it's challenging. I think it's less, yeah, it's like 1.27 or 1.5. I don't think it's 1.25, so I'm actually going to get rid of that, because that's very close. Yeah, there's no shrouding. So we're all the ones that look like header down here. Like, we're just going to ignore these. These are like receptacle. Oh, these are called forked. Oh, that's interesting. Oh, you know what? Like, that's what we want. We want forked. Because you see how these are all very similar. They have the little like notch in the middle and the two little grooves. These are called forked connectors. So let's select forked. This is like I learned a new thing today. Fork. Okay. Okay, great. This will get us down to 8. Okay. So these are all in the same family. So these are the ClickMate. So that's, or Mini Tech. So now I'm going to try to figure out which one it is. Now, I'll say it's definitely not this one. It's definitely not this one. So it's like this one, maybe. This one, maybe. Or this one, or this one. And the difference is, so actually, you know what? Let's try comparing them. I will say, this is risky. I've not done this before. It's not, is it? Could be this one. It could be that one and not that one. Let's compare these 5. Okay. So these are different. So it looks like there's a couple different families. There's ClickMate 502 family, ClickMate 502 433. There's different, the mating pitches are different. This is 2. And then these are 1.5. And then insulation color is slightly different and the insulation height is slightly different. Okay, so one thing I'll say is, I don't think it's this Mini Tech. Let's look at it. Although this could be a compatible piece. Let's look at the data sheet real fast. This looks like it's a compatible part, but it's got, yeah, it's got the little leggies. It could be that, but I think the more likely thing is, I think it's not 2mm pitch. I think it's 1.5. So I think it's one of these 4. And honestly, having calipers would help a lot. And I think these are all very similar. These are the 2 same family. And this looks also very similar in the family. This one, yeah, it's tough to tell the difference. Forked, what's the, I guess it's like slightly different connectivity. Oh, this is a high voltage rating, I guess. And these are not as high voltage. So I think these 2 are the same. I think these are just, one is, this one might be the vertical one. Let's look at the 360. Okay. Another thing to notice is that a lot of these connectors, they have both vertical and like they have right angle and vertical style. And it's the same package, but it's like they just bend the pins a little bit differently. So this one, it could be this. This looks very promising. This one has a little notch. Which one it is, I'll tell you what I would do if I was this person who was trying to figure out which one it is. I'd actually purchase 2 of each of these ones and then like fit test them with the cable to see which one, because it's hard to like know for sure, and they're about $1 a piece. So given that, I don't have this board, so I don't, I can't fit test it. I think I would get these 4 pieces. I would pick up, 2 of each and try them. And, if they work, great. If I don't, I have a couple extras, but at least, it's cheaper than, getting a whole new motherboard design. But if I had to pick one, it was like, okay, you have to pick one because you only get one pick for the Great Search. It would be this one because there's the most in stock. And I have found that whenever you go with the item that has the most in stock, you're most likely to win. if you're going to roll the dice, that's how I roll the dice. So this is my pick for the Great Search. I believe, even though it's photographed right angle, it's a vertical connector. I think this one should work for repairing that 3D printer motherboard.
And that's a Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
Alrighty, that's our show for this week. Thank you so much, everybody. We'll be here throughout the week. All regular shows leading up till Thursday and Friday. Thursday, company holiday. Friday, we'll have a big sale. But some of the live shows we won't be doing, but we'll probably be doing Jessica Ladyada this weekend coming up. Thank you so much, everybody. See
Thanks,
you
everybody.
next week.
Bye.